right, welcome back to our stoichiometry party. This is 8.3, calculating percent yield, but in reality, it's a little bit of 8.1 and 8.2 as well because they're all connected together. So it'll be a good review of all your stoichiometry. So first things first, let's write our balanced equation. We've got zinc reacts with hydrochloric acid to produce zinc chloride. I'm not going to go through how to write these, but notice how I balance my charges. I write ZnCl2. If you need help with that, go back to the 5.5 tutorial. And hydrogen gas. Remember, hydrogen gas is H2. It is diatomic. Again, if you need help with that, go back to the 6.2 writing equations from words tutorial. So I've got 2 chlorines over here. Let's make 2 chlorines over here. 2 hydrogens, 1 zinc, 1 zinc. We're good. Equation balanced. Now you'll notice that in this problem, the BCA table wasn't given to us. Sometimes we do have to write in our own BCA table. That's okay. I think we can handle it. So we're going to write in our own BCA table there. I have 4.61 grams of zinc. We know from last tutorial, only moles go in the BCA table. We're going to get that tattooed onto our arms so we never forget. So 4.61 grams of zinc. I'm going to convert that to moles. So I'm going to look at my periodic table there. Hopefully you have your periodic table handy. Throw that into your calculator. Again, if you need help with mass to moles or moles to mass, you need to check out the 7.1 tutorial. Don't you love how stoichiometry brings everything we've learned together? That's why it's the top of Chemistry Mountain. So let's see, I get 3 sig figs, so 0.0705 moles of zinc. It says it's allowed to react with hydrochloric acid, so we're going to assume that is excess since we're not told how much. And we know we always start with zero product. Reaction hasn't happened yet, so we can't have any product. We're going to use up all that zinc. So I'm going to subtract out my 0.705 moles. I see I've got a 1 to 2 ratio here. So I'll do that over here. Got 0.705, get a little more room. 705 moles of zinc. And I'm looking for moles of HCl. I'm going to abbreviate my work a little bit because I'm running out of room. Just squish it in here. And I know it's 2 HCl's for every 1 zinc. And again, that's from my balanced equation. Remember, I used my balanced equation to get those numbers. Also remember, I didn't write in the ones in front of my compounds that only have 1. I could write them in here, but our convention is to leave them blank. You do whatever works for you. So if it's helpful for you to write in the ones, you feel free to write in those ones. All right, so I solved that, and I find out I have to do 0.705 times 2, and I get 0.141 moles of HCl. My other ones are 1-to-1 ratios, 1-to-1 zinc to zinc chloride and hydrogen gas. So at least that's easy. I'm not going to write out those proportions because they're 1-to-1. So it's going to be that 0.0705 moles again. And of course it's plus because we're adding product as we make it. Then I do my easy math. I have 0 zinc left. I still have excess hydrochloric acid. And I have 0.705 moles of zinc chloride and 0.705 moles of hydrogen gas. Now notice how this number, I didn't use it anywhere yet. It says that I actually produce 8.56 grams of zinc chloride. That's how I know I don't need it for my BCA table because it's the actual amount that was produced. So I saved that for later in percent yield. Don't put that number in your BCA table. If it says actually produced, just set it off to the side for later. You'll get there. So This is in grams, which means I'm going to need my zinc chloride in grams. I need my theoretical yield. So I have 0.05 moles of zinc chloride over X grams. I need to add up my molar mass for zinc chloride really quick. Make sure you do 2 chlorines. And make sure you, of course, use the right element on the periodic table. Chlorine is Cl, not just C. I get 136.272 grams for every mole. All right, I'm going to multiply that by my 0.0705. And that means I produced, to 3 sig figs, 9.61 grams of zinc chloride. So that is my theoretical yield. That is my theoretical yield. So that is one part of the problem. The problem does ask how much zinc chloride should you get. So that's one answer. But this question is actually asking 2 questions. The second one is what's the percent yield? So this is my theoretical yield. That's my first part of my answer. I'm going to erase this work up here so I have a little spot to write it. The other part, and I'll even write it in a different color, is percent yield. So percent yield is going to be our actual over our theoretical. So the percent yield is going to be the actual over the theoretical. So the actual is 8.56 grams. That's given to us in the problem. Over the theoretical, 9.61 grams. So that's my theoretical. And then I have to multiply it by 100 because that's how you get a percent. I'll do 8.56 over 9.61, and I get an 89.0% yield, which is pretty good. Your percent yield is not going to be more than 100. If your percent yield is more than 100, you somehow made more atoms. We know that's not possible. We can't make more stuff than we have. So if your percent yield's over 100, something went wrong. Go back and check your work. Your percent yield should also not be crazy low. You shouldn't get a percent yield like 20%. That would mean someone really, really messed up the experiment. So that's probably not right either. You know you've done it right if you're somewhere around the 90% range. That's a pretty typical percent yield. Remember, experiments don't work in the real world like they do on paper. So our theoretical yield is how much you should get in a perfect world. We don't perform experiments in a perfect world. Sometimes we don't produce as much product as we calculate that we would for a variety of reasons. So that's why we calculate percent yield to see how well we did the experiment. So how close did we get to the perfect world value? So in this case, they're about 11% off. That's not too bad. Our goal is to get within 10% of the actual value. So that is theoretical yield and percent yield. Quick review on the steps we did. Step 1, convert your mass to moles. Convert your mass to moles. Step 2, fill in your BCA table. Step 3, calculate your theoretical yield. So that's moles to mass. And we added an extra step here. Step 4, calculate your percent yield. So these are a little bit of a bigger problem, but it's all stuff you've done before. We're just sticking it together.